Hello, you're welcome. All right, now the topic before us is logarithm, right? So now I'm going to start by defining the term logarithm. Now, previously we actually looked at indices, right? Which we said that an indices is actually the plural form of index. And what's an index? An index is simply a number, okay, in an exponential form, or a number that is raised to a power, right? So this, we said, this is the base of a number, and this is the power, right? So this is what we already treated, right? Okay, so now logarithm. Now, in a simple term, I will simply define logarithm as a mathematical, okay, process or statement which is used to evaluate or to determine the power of an index number. All right. So we use log, okay, log to actually evaluate, to determine the power of an index. Okay, for me, let me illustrate that. For example, let's say I have an index number index number y, which of course is a raised power n, right? And I want to know what this a is. I want to know what the power n is, so that at the end of the day, when I raise a to the power of n, I should have y. All right. So the only way I could actually find what n is to take the log of y, then in the base of a. Okay. For instance, if 4 is equal to 2 raised to the power of x, and I don't know what s is, okay, I don't know what s is, so that when I raise 2 to the power of s, I will have 4. I don't know what it is, and I want to get it. Okay, to get that, I will simply say that x is equal to the log of 4, of course, to the base of 2. And of course, when you do the log of 4 to the base of 2, you have 2. All right. So you then discover that a log actually gives you a direct, okay, process of finding the power or the exponent of an index. All right. So I hope that is well understood. Now, in this tutorial, we're going to be looking at the laws of logarithm. Now, it is these laws of logarithm that will actually help us evaluate question in logarithm, right? So I'm going to be looking at it one after the other. So we are going to start with number 1 law, and each law I'm going to give it a name, right? Now let's say you have a log of x in base b, in base a. Let me use base a. Then I'm now having log of y, and the base is still base a. Now, one thing about these two logs is that they have the same base, right? So the law of logarithm, when you have two log adding each other and they're of the same base, that applies is known as multiplication law. Okay? How does it work? So it simply means that I'm going to multiply the two log x times y, then in the base of a, right? I call this multiplication law. So if you want to reference it as multiplication law. So which simply means that if I have something like this, example, if I have log 8 in base 2, then I have log 4 in base 2. So looking at these two log, they are of the same base, and of course they are the their addition. This is addition, right? They are adding each other. So of course, I will apply multiplication law, which goes like this. Log, that's going to be log 8 times 4 in base 2. That's number 1 law. Let's look at number 2 law. Number 2 law is known as division law. Okay, in division law, let's say we have log x in base A. This time around, I have minus log y in base A. Okay, now the 2 log is of the same base, and of course the operation here is difference minus. All right, so in this case it becomes division of the 2 log. So that's going to be log x all over y in the base of A. I go to the next law. The next law is known as power law. Okay, now when you have a log, let's say the log x is raised to the power of y, of course in base A. The y here is the power of x. According to the power law of logarithm, power of a log can always go to the back of the log. Okay, so the y goes to the back of the log, so I'm going to have y log x in base A. For example, if I'm being given log 8 in base 2, which we also know that in index, all right, 8 is 2 times 2 times 2. 8 is something as 2 raised to the power 3, right? So 8 is going to be log 2 raised to the power 3, still in base 2. So applying power law, this is going to be 3 log 2 in base 2. All right, so this is known as power law. Reference it as power law. As we proceed, okay, the next law is known as log of the same base. Log of the same base. If I have log A in base A, it's going to give me 1, in as much as they have the same base. So for example, log 2 in base 2 is 1. Log 3 in base 3 is 1, okay? etc. in as much as the same base. Then number 5, I'm going to bring another law known as reciprocal law or inverse law. Let's say you want to invert a log, right? Let's say you have log b in base A and you want to reverse it to make b the log, to make b the base and a the log, right? You want to just find the inverse. All right, to do that, that's going to be 1 all over log excuse me, that's going to be 1 all over log a in base b. All right, so it's just a reciprocal. That's what I just did. For example, a situation where you're being given a question, okay, let's say log 2 in base 4 and you want to solve this, okay. Now you now wish to make the 2 the base, which normally 2 supposed to. It is easier for me to simplify this, okay, if 2 were to be the base. So I have to reverse it, right? So for me to reverse it, I will do 1 all over log then 4 in base 2. So these are basic logarithm. Then there's another law known as change of base. Another law or a principle of logarithm. I will just, okay, change of base. It's a change of base formula. Now, if you want to change a log to a different base entirely, you apply this law. For example, if I have log x in base A. I want to change it to base B, a different base entirely, okay, from the logarithm. All right. So if I want to do that change of base, look at what's going to be. I'm going to take log x, then to the base of B, then divide by, I will also have to take log A to the base of B. All right. So you're gonna see a situation where all this laws is being applied, and that's what we're going to be looking at. All right. Now I think another video we're going to delegate on that video for the proof of the laws, right? But I'm interested in application, so let's go to application. So I'll be giving some questions, right? Then we'll do justice to them. Example. The question goes this way: evaluate the following. Okay, so I have a part of the question. So we'll have log 32 in base 2 minus log 8 in base 2. Okay, let's say plus log 4 in base 2. B, let's say you have log the square root of 27 in base 3 plus log 9 in base 3, all divided by log 81 in base 3. Now let me solve these two questions. Solution. Okay, so starting with the very first question. Okay, this, as you can see, okay, one thing is common with all this log: they have the same base, so it is easy for me to simply apply the multiplication and division law. So for the minus, that'll be division law. For the plus, that's multiplication law, right? So what I would do is I'll do log, since it's the minus, remember minus is division law, that's going to be log 32 then divided by 8. Okay, don't forget the base is base 2. Then for the plus is multiplication law, so I multiply by the log 4. And of course with your calculator, I think you can do this, right? 4 divided itself 1, divide 8, that's 2, then 32 divided by 2, that's 16. So that's going to give me log 16. Okay, can use your calculator to confirm 16 in base 2. Then the next step now I'm going to apply is the step that deals with power. All right, remember 16 can be raised to a power. Okay, 16 is actually a multiple of 2, okay, of powers of 2. How do I know? Okay, if I have 16, let's look at how many times I'll multiply 2 before I get to 16. 2 times 2. 2 times 2 is 4. 4 times 2 is 8, right? Then 8 times 2 is 16. So invariably now I can simply say that log 16 is the same as 2 raised to the power 4, right? Don't forget our base. So now I have converted the index, the number here to an index form, okay? To an index form, and of course, in an index form, it now has power. So I will apply power law. Remember the power law, the power goes at the back of the log. Power always goes at the back of the log. So I have 4 log 2 in base 2. So at the end of the day now, I will apply this. Remember this law, log 2 in base 2, log of the same base is always 1, alright? So 4 times 1. So my final answer to the question is 4. As simple as that. Let's look at the second part of the question. log square root of 27 plus log 9 inverse 3. Okay, so in this case, you know what I'm gonna do? Since I'm having the same base, okay, I'll apply multiplication, and of course this one I will do it, okay, individually in the denominator, right? Right, so I'm having log excuse me. So I'm having log the square root of 27 times 9. Don't forget. Okay, so inverse 3, that's multiplication law, right? Then divided by, still write down log 81 inverse 3. Okay, so of course, if I'm multiplying square root of 27 by 9, okay, this will be easier if I should convert what I have here in index. 27 to index, 9 to index. 27 to index is the same thing of what the square root of 27 first is going to be the same thing as 27 raised to power 1 all over 2. If you don't know how I got this, I'm very sure that you should go back to the tutorial on index, right? You should go back to the tutorial on index. We call that root law. What I just applied here now is called root law, right? So log 81 inverse 3. Okay, let's go there. So now I have not applied my index to this, okay? So that's what I want to do now. So it's going to be log, of course, 27 in an index form. Remember, 27 is a multiple of 3. 3 times 3 times 3 is 27, right? So that's going to be log raised power 3. Don't forget, right? 3 raised power 3 is 27, right? Then don't forget I still have another power there, that's 1 over 2. Then of course for 9 is 3 raised to power 2. Okay, and I'll still do same to this. 81 is 3 raised to power 4. You can confirm that 3 times 3 times 3 times 3 is 81, right? Okay, so let's go there. So this is gonna be equal to log 3 all over 2, right? Then times. Now I am only working on this index. Don't forget my base. I still have the base here. So all I'm doing here is just to simplify this index before I can now apply whatever I need to apply. So this is now indices, right? Remember indices, all right? Indices. In indices, once you have multiplication, it becomes an addition law. So in indices now, 3 raised power 3 all over 2 times 3 raised power 2 is something as 3 raised power 3 all over 2. Because of the times in indices, okay? Because of the times you actually add the powers, right? So that will be 3 raised power 3 all over 2, right? Divided by plus. Okay, so this is indices. Just in case you've forgotten that, you should go back to the tutorial, all right? Okay, here we go. Okay, let's flow. So using LOCM method, I think we can actually evaluate 3 over 2 plus 2, right? So this is gonna be log. If I should evaluate the LOCM of this 3 over 2 plus 2 is actually 2, right? Excuse me. Let me write it. If I now bring out this, okay, LCM is 2. Then 2 divided by 2 is 1. 1 times 3 is 3. Then plus, this is all over 1. I hope you know that, right? 2 divided by 1 is 2. 2 times 2 there is 4. Are we good? I believe we are, right? And so this is going to be I can still write it down, or I can apply the power law here. Take the 4 at the back, right? Remember power law. Okay, so this is going to be log 3 plus 4, of course, is 7. 7 all over 2, right? So I'm having, I can still apply power law here. So to make my simplification easier, and of course to finish up faster, right? So now I have 3 plus 7 all over 2. That's 7 all over 2, which is the power of 3. Applying power law, the power goes on the back of the law, so I'm having 7 all over 2. All right, then log 3 in base 3 divided by 4 log 3 in base 3. Okay, I think we almost come to the final. Log 3 in base 3 is 1, log 3 in base 3 is 1. So I have 7 over 2 times 1, then 4 times 1. So my answer becomes 7 all over 2, right? Then divided by 4, right? You can still simplify this by doing 7 all over 2, right? Divided by this reciprocal. That's times 1 all over 4. Okay, so I hope I'm not mistaken. Yes, I'm not. So my final answer is what? 7 all over 8. Okay, so I'm just giving you a simple approach to solution of logarithm. So we can now go to solve some other complex questions. So, and I will actually urge you to go through the indices tutorial, just in case you probably must have forgotten some laws of indices, right? And or you've not actually gone through that tutorial, you can do that, because the question we're going to be solving, okay, on logarithm will also have some connection with indices. All right, see you in the next video. Thank you very much.